In this lecture, we want to test the things that we said in the previous lectures using a application named Wireshark. Wireshark is the best network traffic analyzer out there if you want to see that how a packet is sent and what is a packet and all the details of the packets in a communication. You should use Wireshark. So this is the main page of the Wireshark, and these are all the network in all my active network interface cards in here that you see. Some of them are virtually created because of the VirtualBox, and some are real and some other are external. For example, wireless network connection 5 is an external wireless network interface card, or wireless network connection in here is the built-in niche that my Windows host is currently using. I'm running the Wireshark in the Windows host right now. In the next lecture we would see it in the Linux also. So in here I want to press the capture button, which is actually in here. This is the capture button. We press it to start capturing packets, and let's go to my browser, which is the Firefox in here, and go to a website, for example Kali.org. We hit enter, and while it's trying to browse the Kali.org, and you see in here we go to the Wireshark and stop the capture. You see these are all the captures that have been all the packets that have been captured, some of them because of we browse the Kali.org and some not. We want to filter the packets to capture all the packets that have been using the HTTP protocol. We hit enter, and these are all the HTTP protocols in here. We just want to analyze one of them based on the things that we learned in here, that how a packet moves through the network stack. Now if you look, this is a packet which works with the HTTP protocol. It says that the length is 382 bytes, and these are the source and destination. The real packet in bits is in the lowest tab in here that you see. If I scroll down, you look at all the bits that are represented in the bytes. You see these are all the packets in the binary format, the middle one in here. The second tab is the human readable form, categorized based on the layers that we explained in the previous lecture. So the first one is the total information of the whole packet, 382 bytes on wire, which is equivalent to 3056 bits if we just multiply this byte by 8. Now you see we have 4 layers. The first one would be the Ethernet. So if we look at the representation in here, you saw when a packet is captured we have 4 different layers of a packet. This is the thing that we see in the Wireshark: Ethernet, IPv4, TCP and HTTP. You see Ethernet, IP, TCP, and the application layer protocol or the data, which is the HTTP in this example. So we opened the Ethernet header first. We said that the Ethernet is stripped away in the first layer, the network access layer. So if we open it, you see that when I click on the destination, look at the lowest tab, we see 6 bytes or 6 times 8, which is equal to 48 bits. So these first 6 bits are the destination MAC address, the physical MAC address, which I said is written on the back of NIC. Then we get to the source MAC address, which is the which is the MAC address of my wireless NIC. Right now, if you look, this is the physical address written on the back of my NIC. Then we get 2 bytes, which is actually the type of the protocol in the next higher layer. So somehow after the Ethernet is stripped away, next network access layer protocol module should know that which protocol in the higher layer it should deliver this packet to, the remaining packet to. Is it the IPv4 or is it the IPv6? The information for doing this thing is written in the Ethernet. So when the Ethernet module looks at this information, it sees that the type of the next higher layer protocol is IPv4. So it would separate the Ethernet header, delivering the rest of the packet to IPv4 protocol module in the next higher layer protocol or internal layer. Now we get to the IPv4 header. IPv4 header at minimum is 20 bytes. We are not going to talk about all of these things. I have other courses explaining about all of these different headers in detail. But some of them that I want to notice, for example, this specifies the IP version, which is IPv4. This specifies the header length, IP header length, which is 20 bytes in the 4-byte words. Then we get to some other headers in here for fragmentation and other things. You see we have total length. The total length gives us the length of the IP packet, which is equivalent to 368. If we want to calculate the length of the whole packet, you would add this number by the Ethernet header length, which is 14. 14 plus 368 would give us 382, which is the length of the whole packet. The thing that I want to notice in here is the protocol field. You see in the lowest tab by the blue color, you could see the real bits. So protocol is expressed using 1 byte or 8 bits. You see, this is the 1 byte or 8 bit 000000110, which is equal to 6 in the decimal representation. And computer knows that this value means that the next higher layer protocol is TCP. So because this value is 6 in decimal or this value in the binary, the internet layer or IPv4, after separating this header, knows that the rest of this packet, which we call it a TCP packet, should be delivered to the TCP in transport layer and not UDP. So it would deliver it to TCP in here. Now, some of the other more important information in the IP header are source and destination IP address, which based on this information, the different routers through the process know that how they should proceed with directing this packet. Source is 192.168.1.44, which when this packet gets to the router, we said that the router would do a network address translation to translate it into its own public IP address. And also we have the destination IP address, which is equal to 192.124.249.10, which is the IP address of the Kali.org. So now let's close this layer and get to the third layer, which is Transmission Control Protocol or TCP. These are all the information in the TCP. Some of them are for error detection so that the packet could be retransmitted. But the important things that we want to notice in here is the port number, the destination port number. So in here it says that the source and destination port number, the destination port is 80. If you look, the source is our private IP address. So what it means is that because we know that web servers or HTTP works with 80, it means that this is a HTTP packet. It goes to a web server which is listening at the port 80. So based on this port number, TCP in here knows that after stripping away the TCP header, this data should be delivered to the implementation of HTTP protocol in the application layer. And then we get to the source port, which is 819. This port number is the port number that the operating system assigns to the HTTP program in our system. So based on this port number, the TCP protocol in here knows that after stripping away the TCP, the data should be delivered to the application that is actually listening to the port number of 819. On the other hand, when this packet is delivered to a web server, because the port number would be 80, it knows that the packet should be delivered to a implementation of HTTP protocol. Now, if we go to the hypertext transfer protocol or HTTP, these are the main data that right now my device is sending to the web server, and based on the HTTP specification, the client and the web server, they both could talk to each other. So every one of these lines has a specific meaning for the web server, which you would talk in the next lecture.